everyone to spread number 9, Python with Andy. Alright, to give a brief intro before we start Andy's presentation, SPREAD stands for Supporting Pair, Respect, Education, and Discourse. And basically, it's just a community event where we try to encourage people to talk and also make friends. So if you don't know everyone in the room, make sure you introduce yourself and finally learn something new while we're at it. Especially now that we're pretty much all graduated, it's good to meet some new people. So without further ado.
Wait, should we go around and introduce ourselves?
All right. I'm Carmen.
I'm Andy.
I'm Wesley.
I'm Bowden.
Hello.
I'm Gilbert.
I'm Crystal.
Anna.
Henry.
I'm Preston.
I'm May.
I'm Michael.
Steven.
Jared.
Jared.
Yay. Okay.
Swag.
Great. Yay. Welcome, Andy.
All right.
Yay.
Go, Andy.
So today I'm going to give a little intro on Python. So the first thing is what is Python? So Python is one of many computer programming languages. And well, what is a computer programming language? It's basically a way where a human can give instructions to a computer. Because computers by themselves, they really can't do much. It's just a pile of junk that can turn on and off. But then with a programming language, you can kind of tell it how to turn on and off in a way where it can actually do something useful to us. So to teach you guys Python, we're going to go through this problem called FizzBuzz that is typically asked when you interview for a software engineering job. And to kind of hype us up for FizzBuzz, I'm going to show some quotes from software engineers online to think about the difficulty of the problem FizzBuzz.
Wait, how do you spell this? Okay.
Yeah. Can someone read that quote?
Want to know something scary? The majority of comp sci graduates can't complete FizzBuzz. I've also seen self-proclaimed senior programmers to take more than 10 to 15 minutes to print a solution.
Here is one other one. Can someone else read that?
You have just identified that this person who completed FizzBuzz is the 1 in 200 applicants who can actually code. Mission accomplished.
And I have one last one. Can someone read that?
A surprisingly large fraction of applicants, even those with master's degrees and PhDs in computer science, fail during interviews when asked to complete FizzBuzz.
Cool. So this sounds like a pretty challenging problem, no? So here's the actual problem itself. Write a program that prints the numbers from 1 to 100, but for multiples of 3, print fizz instead of the number, and for the multiples of 5, print buzz. For numbers which are multiples of both 3 and 5, print FizzBuzz. So what do you guys think is the key point of this problem? Like the key things we got to pull out of this? Because right now it's just kind of, yep, multiples is one of them. What else seems pretty important? Nothing? All right, I'll go through it. So the first part that's important is that you have to print out some numbers. Which numbers? 1 to 100. But for multiples of 3, we want to print out the word fizz instead of the number. And for multiples of 5, we want to print out buzz instead of the number. But for numbers that are multiples of 3 and 5, we want to print out the word FizzBuzz. So let's go and break down this problem some more. So these were the 4 points that I talked about. So how would we do this as a human? Like how would we print out the numbers from 1 to 20? Like say if you had to write it on a sheet of paper, you'd write what? Like 1, 2, 3. Yep, there we go. Cool. So for multiples of 3, we want to replace the number with the word fizz. What's a multiple of 3?
3.
3, 6, 9. Cool. It's basically any number that you can divide by 3 and there's like no remainder, right? Same thing, yep. And then we replace the number with fizz. So for 5, we do the same thing. Identify the multiples of 5. And then we want to replace it with buzz instead. And then for multiples of 3 and 5, I think it's only 15. Yep. We want to do FizzBuzz instead. So now that we truly understand the problem, we kind of looked at what the output of it should be. Open up your computer and go to this link right here. Yeah, so REPL stands for Read, Evaluate, Print Loop. It's basically a way to kind of test your code or just type little bits of it and then you can run it instantly and see what the output is. but I'll dig further into that as we actually use it.
You didn't bring one either.
You could do this on your phone.
Everyone good? All right, cool. So the first step is to print the numbers from 1 to 100, but before that, let's walk through how you would do this as a human, right? So let's say you want to print the number 1. What do you do first? You find a pen and a piece of paper.
Okay.
You pick up the pen with your hand.
I'm following.
You hold the pen in a way where you can print something, where you can write something. Then you want to move the pen so the tip of the pen touches the paper, right? And then you want to move the pen in the shape of the number 1 while the tip of the pen remains touching the paper. Then after that, you lift up the pen from the paper. So that's number 1, right? How do we do number 2?
Same thing.
Same damn thing, yeah. Except you write a 2 this time, right?
Yes.
So these steps, they look very similar, right? So it seems like writing is a very basic function that we all know. So let's kind of simplify the instructions a little bit. So how to print whatever you want. Instead of specifying the exact number or whatever you want to print, we'll just replace it with whatever you want. And then as a human, you understand where to plug in all of these instructions, right? Like if you want to write a 1, for step 5, you would move the pen in the shape of a 1 rather than whatever you want. So let's move this to the side and let's keep going. So how to print for 3, you would plug in the 3 in whatever you want, change it to 3, and then you'd still follow the instructions. So for 4, you would do the exact same thing. But then for 5, you would still do the same thing, but then let's actually change how the right side looks a little bit, because for me, this is kind of confusing, right? Like it's just kind of 2 lists of numbers. I don't exactly know what is going on here. Do I follow number 5 and then I go to 6 on the right? So to make the right side more clear that it's a set of instructions, I'm going to include a def in front of it, which defines the right side as a set of instructions called how to print whatever you want. And then because how to print is kind of long, it's definitely a mouthful, right? Let's shorten that to print. And then here it still is a little bit confusing. Like, is the group of instructions on the right called print whatever you want, or is it just called print? So the context for those set of instructions, let's put those in parentheses. And let's add a colon at the end to indicate that that's the end of the title, kind of. So I'm going to shorten the right side because we all know that when we want to follow something, you don't have to say it explicitly. You can just say print 5. But then still here, it's a little bit confusing, right? So print 5, do I look for the instructions that is print 5? Like, I don't know what to do with the number 5. So I'm going to put those in parentheses as well, so I know that the 5 plugs into whatever you want. So if we were to keep walk down through this, if we were following the instructions on the right with number 5, when we say print 5, whatever you want has the value of 5. So when we follow these instructions on step 5, we replace whatever you want with 5. Do the same for 6. So on step 5, we move the pen in the shape of 6. But thinking more about this, I think you guys are smarter than that. You guys know how to write stuff, right? So like printing is kind of natural to you guys. You guys learned it a long time ago. And in Python, it's very similar as well. There's a base set of instructions that it already knows what to do. So yeah, if you were a human going through this print 7, you know exactly what to do, right? Pick up a pen, write number 7, etc. So instructions like this, Python can understand without including anything else. So if you guys open up Replit and you guys type in that whole set of print stuff, click the run button, and then you guys should see 1 to 13.
Ooh. Wait a minute.
I'll let you guys type all that good stuff in.
Then you can copy and paste the engine.
Can you?
You can copy and paste it and then change the numbers.
Yeah. I thought you copy and paste it and change the number.
My thing's not running now. Oh, I have to
You have to
press
click,
run.
you have to click run.
You gotta click the run.
Oh,
It's a
okay.
click that button.
Okay, okay.
Yeah.
Just do it until you hit number. You just have the empty one. Just copy the empty one. Yeah.
Right.
You don't have to do. We have to do.
Oh my god. Everyone good? Everyone fast typers? Yeah?
That's good.
Get that running? All right, cool. So with what you guys just learned, we're basically done, right? Because we can just print 1 to 100 like this,
That's a
right?
lot.
And then you replace it with Fizz, add in the buzzes, add in the FizzBuzz, we're done, right? That's so simple.
That's the part right there.
So I get a job?
But no, there's actually a much better way to do this because computers are good at things like repetitive tasks. You don't have to specify every single thing out. And there's like a very clear pattern here, right? Like we know that it's the numbers from 1 to 100, and we know for all multiples of whatever, we need to print out something different. So let's pull out the example for 13 again. And let's look at the, I guess, the text explanation for each line. So if we condense all these instructions together, it would be
Great.
like turn all of these things into just one sentence. What do you guys think it'd
Print
be?
the numbers between, or
1
print the
through
numbers
13.
1 through 13.
Exactly, correct. So let's actually restructure that sentence in a way that makes it easier to code it out. And let's be more explicit about some of those things as well. So basically print the numbers from 1 to 13 means that for each number in the range of numbers from 1 inclusive, which means including 1, to 13 inclusive, including 13, we want to print out the number. So let's see how we would turn each part of that sentence into Python. So the first bit, for each, we'll put in for each, right? For each number, in this case, we'll refer to it as n, for each n. And since we're shortening things, we can just drop the each. You actually don't need the each in the syntax. It won't work. But I just included it so it's a little bit easier to grab it at first. Each number in, that's simple, just in. The range, we're going to use the range function for this. So range is something very similar to print where Python already has, or you can just run it as is. There's nothing to build out there. And range will take several pieces of context, several inputs to indicate what it's going to output. And we want range of numbers from 1 inclusive to 13 inclusive. So we're actually going to put 1 comma 14, 1 to 14. So the reason why we're putting 14 is because range will expect the second piece of context to be exclusive, meaning that it won't include that number. So 1 inclusive to 14 exclusive is the same as 1 inclusive to 13 inclusive. Now after that, we can see that the I guess the case for this loop is basically done, and in the English you can see that we have a comma there to indicate that we're going to do some work based off of the case up here. So we're going to insert a colon. Now print the number n. You guys already know what print does, right? You guys just print all the numbers. But if we insert n, it's going to print out the number. It's going to print out each number in the range of numbers from 1 to 13. Now, one thing we also want to do is add a tab before print to indicate that it's part of that loop. Otherwise, Python will try to execute it outside of it. And now, if you guys try to run it, you guys should see the same output as those 13 lines that was printing 1 through 13. So you can see that it saved us a lot of time there. So yeah, the outputs of both of these should be identical. But we just don't want to stop at 13. We want 1 through 100, right? So change it to 101. Yep. So right now you can kind of see like what the computer is really good at, like repetitive tasks. For us to tell the computer to do something 100 times, it really only took like, what, 2 lines here? Versus if we were doing it by hand, we'd write every single number out until 100. And yeah, at this point, what you guys have is the same as doing all of this. Now let's keep moving on to the next part of this question. And that is, for multiples of 3, replace the number with the word fizz. So how do you determine that something is a multiple of 3?
If you can divide by 3
With no remainder.
with no remainder.
Mm-hmm. So if you divided by 3, yep, if n divided by 3 has a remainder of 0, do you guys know of any math way to do this besides just dividing it by 3? Do you guys know what a modulo is? Can you explain it? Because I can't. I probably won't be able to explain it soon.
So think about it like this, right? The numbers that we use now, we typically do in sets of 10. instead of thinking about numbers in sets of 10, think about it in sets of like, and if it's like modulo 2, you think of it in sets of 2. So for example, like 1 is 1 mod 2. 2 is also known as 0 mod 2 because it's completely divisible by 2. 3 is considered 1 mod 2. Like every number that's odd is 1 mod 2. Every number that's even is 0 mod 2. I hope that makes some sense. And then if it's like mod 3, it'd be like there's 0 mod 3, which is numbers divisible by 3. And then there's 0, 1, and 2. In that world of numbers, there's only up to 2. Or 0, 1, 3, 2. And then it's like mod 4, it goes up to 3. I hope that made some sense.
Okay, that explanation was far more complicated than it had to be.
Sorry.
So when you do a number mod another number, you're basically dividing the first number by the second number, and you get the remainder as the output. You guys kind of get that? That makes sense?
Okay.
Good example.
Yes. No. What example?
So 3 mod 1 is 0 because there is no remainder when you divide 3 by 1. If you divide a number by another number that has a remainder, you would get that out.
So 3 mod 6 is 2. 6 mod 3?
6 mod 3.
Yeah.
Okay. So mod
6
is
mod,
like...
yeah. 6 mod 3 is 0. It's 0. There's no remainder.
It's divisible by
Yeah.
3. So
It's divisible
It's
even.
not-
You're taking them
Oh,
as
okay, got it,
Mhm.
got it, got it. Okay.
7 mod 3.
That's so hard.
So yeah, we
It's 1
can
mod
use.
7 mod 3.
7 mod 3 is still 1 mod
Just
3.
1.
7 mod...
Because there's one remainder after
Okay.
you divide by 3.
Mhm.
Yeah, yeah.
Yeah, so one way we can determine if a number is divisible by 3 is we take the number mod 3, and if the result is 0, then it's a multiple of 3. So we'll start with the first bit, if. You can type in if right below print, and you want to make sure that it's aligned with the beginning of print, so you want it to be 1 tab in. I think Replit will take care of that and make sure that every line below it is always going to be on the same alignment.
Yeah, just as long as you click enter after the colon.
Mhm.
Wait,
What's up?
nothing. Go ahead.
So the next part is the number mod 3, and the sign for mod is %. So n%3. If it equals 0, we can test for that by doing double equals 0. So the way you do direct comparisons or comparisons overall is you use double equals, because if you just use one single equal, it's actually assigning a value to something else, which probably go through in another spread. And that comma right there indicates that it's the end of that case right there, so we're going to put another colon. And what we want to do is we want to print the word fizz. So right below that, we'll just include print fizz. And you want to make sure that it's tabbed in 1 over then the if statement to indicate that it's part of that if statement. So if you run this right now, you'll see that it'll go 1 to 100, but then it doesn't replace the number, right? You'll see 3, and then you'll see fizz. So the way we can handle that is if we look at our initial case. Some of these things are similar, right? So like if we wanted to replace it, we probably want to check for if the number mod 3 equals 0 first, and then if it's not, we'll print out the number rather than going back and replacing it. So if we change up the English part a little bit to if the number mod 3 equals 0, print the word fizz. Otherwise, we want to print the number n. And in that case, we're basically replacing the number with fizz, right? But let's actually change up this English a little bit more. Let's use the word else, because it's a shorter word. It's a little bit more convenient to type. So after that, you want to put else. And you want to make sure that it's aligned with the if statement, because this is still part of the if statement. And we want to print the number n. We can just move what's on line 2 down to 5 inside the else block. So if you guys run this now, you guys should see that for all numbers that aren't multiples of 3, it'll display the actual number. And for numbers that are multiples of 3, you'll see only Fizz. And that's basically equivalent to all of these lines right here. Now let's grab the other part of the question. So for multiples of 5, replace the number with the word buzz. And let's try to include it into that block of English up there. We can do, yep. Yeah.
I was going to say put it after print Fizz.
Exactly. So for multiples of 5, replace the number with the word buzz. We can kind of cram it up into this block of English here by saying blah, 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 print the word Fizz. Else, if the number mod 5 is 0, print the word buzz, and then we retain the rest of the print the number and down there. So the first part is else if. The way we plug that in there is above the else statement and below the print Fizz. We want to insert an elif. It's basically shorthand for else if. If the number mod 5 is 0, so this is basically identical to what we did before. So n%5 this time, double equals 0 with the colon. Then we want to print buzz. So once you guys do that, you guys will start seeing the multiples of 5 become the word buzz instead in the output. This all make sense to you guys?
So you have to use elif.
Mm-hmm.
What if you use if instead of elif?
So you can use another if statement, but the thing is, if you chain them all together, it means that
Oh yeah, it doesn't.
That's not
change
gonna
the
work.
words.
if you chain them all together, it means that only one of these blocks will be run. So like if n mod 3 is 0, it'll print out Fizz, and then it'll throw away the rest of the blocks.
Okay.
So if it goes to the first if statement and say it's a number 5, n mod 3 is not 0, so it goes to the second one, and then it sees that n mod 5 is 0. It'll only do print buzz, and then stop right there and throw away the rest of it. So if you get a number like 1, for example, that doesn't fulfill the 2 cases right there, it'll go all the way to the else. So if you chain up the if statement, it ensures that only one of these things will get run. It's definitely possible to do multiple if statements, but the thing is, unless you include some more code to stop where you want to stop, it'll run all of them. And yeah, so the stuff you guys have on your computer right now is equivalent to all 100 lines right here, where we manually print out 1 to 100 and replace Fizz and buzz. So the next part of this is for multiples of 3 and 5, replace the number with the word FizzBuzz. And we're going to do something similar here where we just try to plug it into the English right there. Toss in a else if statement. And the way you do that in code is going to be identical to what we just did. You want to put in one more elif. Number mod 3 equals 0 and mod 5 equals 0. And the way you can kind of combine both of these together is just by adding a and in between. So else if n mod 3 equals 0 and n mod 5 equals 0. So when you use the word and, it means that both cases have to be correct for it to actually go in. So if it's one or the other, it's not going to work. And we want to print the word FizzBuzz, so that's very simple. We just do print FizzBuzz. So try running this now and see what the output is.
Yep, here.
Does it look correct? Are you guys seeing FizzBuzz? No, right? So the thing is here, the stuff I talked about earlier where only one of these if statements or one of these if blocks will get run, it's because if the number is a multiple of 3, it'll go straight into that first if statement right there. It'll go onto line 3, print Fizz, and then it'll throw out the rest of it. So what we need to do here is change the ordering a bit to make sure that the case for multiples of 3 and 5 gets run first before all the other checks. You guys following?
Yeah, so that'll be our if.
Yeah. So you basically just want to take this statement and move it up to line 2 and shift the rest of it down. And when you guys run it now, you guys should see the right output.
Oh, can you explain that again?
Yeah. So when we had it at the bottom, for numbers that are multiples of 3 and 5, like the first if statement, that statement there is correct, right? So like a number that is a multiple of 3 and 5 is definitely exactly, yeah. So it runs the first one and it tosses away the rest of them. It never gets to line 6. So if you move it up, it makes sure that 3 and 5 is handled first before it checks for the individual ones. And now what you guys have in 9 lines is identical to this 100 line thing right here. And that's it.
Oh, perfect.
So one thing you guys can try right now is do something where you print out only the numbers that are even.
Only the numbers that are.
Yeah.
You gotta use mod again.
Yeah.
Same range?
Yeah, from 1 to 100, only numbers that are even.
What do you want to print out?
The number itself.
Oh, the number itself.
Yeah, so your output should be
So it's-
2,
if
4,
it's
6.
not just
Don't do
upgrade.
anything, yeah.
Oh, may I see your
So what do you go for that?
So, well, no, you just don't print anything.
Yeah.
Oh, just, oh, okay. Okay, that's okay. Sorry, do I delete this though? Is there a way
You
to
comment it out. I think it's like shift.
Is it, that was dollar sign.
No.
It's not dollar sign?
I don't know,
It's like
branch
shift
out?
shift one of the slashes. I forget which slash it is. Yeah.
Oh, I see, I see what you're saying.
All right, cool. So that is basically it. You guys have solved one of the more difficult questions when interviewing for a software engineering job.
Hey,
Oh, it's
we're
hashtag.
qualified.
It's hashtag.
Huh?
It's hashtag.
Oh, yeah, it's hashtag.
Why can't a lot of people do it?
I wonder.
What's up?
I mean, you gave us the answer, but like, what's
I'm
so
definitely.
hard to other people?
So it's hard because most people that go through CS programs and stuff, they don't actually program. A lot of it is going to be theory, and theory isn't applicable. It's not applicable inside a business. So like when you work professionally as a software engineer, your job is to translate business requirements into software products. Like if you know about theory, that's cool, right? You can make it efficient, but if you can't make anything that people want to buy, then that's pointless.
Oh, who are those people that you coded?
Oh, they're just random people who had a lot of thoughts on this question because this challenge is actually like a pretty popular one, and people use it to talk a lot about how most programmers can't do shit.
Yeah.
Do you guys have any questions? No?
What do you use Python for?
So the best thing about Python is that it's very versatile. There's a lot of modules for it. So if you're a data scientist, you might use it. If you're a business analyst, you might use it to clean up data. If you are just a normal software engineer, say if you work in machine learning, you would use it as well because most of the popular modules for machine learning and AI work with Python. If you are a web developer, you'd use it as well because there's a lot of back-end frameworks for it. It's extremely versatile and it's like very easy to pick up as well.
This is pretty hard.
But it's pretty straightforward though, no?
Yeah. Like the syntax itself is very close to normal English.
Like
So
compared to like what, C++ and
Yeah.
Java and shit?
Yeah, it's very similar to Excel formulas.
Yeah.
Mhm.
Are you gonna teach us that Dave thing that you were working on?
dude, I didn't solve that shit. It's unsolvable. man.
Impossible.
Yeah.
It's so it doesn't read the code.
Yeah,
Yeah, it
it's
ignores
it ignores it. It's just for people to read it.
Oh.
How do you edit
wants another button?
It doesn't run.
Give us another problem, man. What more?
Yeah, I can build on what you guys just did.
You can't just.
You want to learn some more?
Yeah.
And why not?
Do you guys remember the stuff I was talking about earlier with the def and shortening how to write?
Yeah.
So there's some things we can do here. So there are pieces of logic that are very identical. Like if you look at line 2, this stuff right here, it's identical to this, right? So we can actually write this in a way where we only have to write this logic once. And that's actually something that's very important in software engineering. It's called do not repeat yourself. So the reason why this is done is so it's for easier maintainability and for better testing. So whenever you write software, you ideally should write unit tests with it, which means that you want to toss in a bunch of inputs and then you want to compare the outputs to make sure that it actually does what you intended to do. So if we had the logic duplicated in 2 places, we would have to test it twice. But if we just wrote it once and referred to it in 2 places, that's only once, right?
Yeah.
So what we can do is actually define a set of instructions that does only this, and then call the set of instructions where we want to use this. So to start a function, we started with def. We're defining a function. This one is, then we're going to name it something that we can easily identify by, multiple of 3. And we're going to take in n. Now here we want to copy out the logic that we use to determine if a number is a multiple of 3. Toss it inside the function. And if we tried to just run it right now, so replace this bit with multiple of 3n and the one below as well. It's not going to work. Does it still work?
I think you have to clear it.
Oh, yeah. Yeah. So you can see that anything that uses multiple of 3 no longer works. That's because inside a function, like this logic is being run, but there's nothing that's really being used by it. So what we want to do is we want to return this outside of the function. So like in that set of instructions, there's typically something at the end where you use the output, right? And that's what the return basically is. So if you try to run it now, it should work. Yeah. Now try doing this for the multiple of 5 as well. It should be very similar to this.
Yeah, I thought I should
God damn.
I just got really. Why she just says FizzBuzz like the whole thing. Like that.
Whoops.
Don't make it.
You said delete it.
Yeah,
I forgot. I didn't know you had to clear it. I thought I did not write it. I didn't know we were clear about it.
Yeah, and then you do that one.
Did you guys get it?
And you make
Oh,
the
okay.
definition by
Damn.
Sorry.
That was like a knee-jerk reaction.
It's like, no, that's it.
Yeah, up this one.
Boss. Just kidding.
You guys good? Yep. So you guys should have something similar to this, right? Multiple of 5 that takes in n, and then you return n mod 5 equals 0. And then you basically want to use it inside the if statements where we had the n mod 5. And then when we run it, we can see that everything works. What other things do you guys think we can optimize here? Like, is there anything that's still very identical? Like any patterns you guys can see?
Oh my god.
So one thing I see is that the string fizz and buzz. So fizz is used consistently in FizzBuzz, right? And fizz by itself. And buzz is used consistently in buzz and FizzBuzz. So one thing we can do here is we can create a constant. A constant is something that constantly just has one value, and then we can use it in both places. So if we ever wanted to replace fizz inside fizz and FizzBuzz, we can just replace that constant versus changing it in these two different places here. So to do that, we can define a variable. We'll call it f. And then we'll just use one equal sign this time to give it a value. And we'll call this fizz. And then we'll define a b that has the value of buzz. So how would you guys plug this into the print
No quotes, right?
No
functions?
codes.
Yeah. This is going to be b. This was going to be f. So to join them all together, it's pretty simple. F plus b. Yeah. And then when you guys look at the output,
I broke my shit.
It's right there, dude. Just copy that shit.
I did, but it's exactly the same.
What?
I don't know what I did. Okay, cool. Okay, whatever. A plus B.
Cool. I think this still has the same thing.
all right, cool. That's about as far as I can go without introducing more new concepts. I'll save that for a later spread. Data structures?
It's alright.
Is it more efficient to have a code that defines things or to have like a short code? Like this is what, 18 lines? Earlier we were like at 9. Is it better to have it more defined or?
It depends on what you're doing. So for this specific problem, you should keep it to as little lines as possible because all these optimizations are necessary because this is such simple of a program. But then once you get into bigger ones, it does make sense to abstract out like the end mod 5 and the end mod 3 into a separate function if you're going to reuse it a lot. Basically, I think that if you're going to use it more than once, you should abstract it out.
That's the only thing you need, but if you put that in there, you should be fine. Yeah, that's it.
Damn, Steven, you just gotta type what's on the
Yeah,
screen.
that's what I'm saying. But no, but I think it's beneficial, like, because for this now, because all we need to do now, we can reuse this function for a lot of things, right? Because you just need to change the definition. So I think that's what, right? You can just reuse the structure,
I gotta look to see that happy reactor.
right? Couldn't you use this for a lot of different things?
Yeah, so there's actually one way where we can make these two functions even more reusable, and then we can actually so we can turn it into one function, and just use it in multiple places. So what's the difference between these two functions? Like they're basically identical except for the 3 and 5, right? So we can pass in context for what we want this number to be. So let's call this x, and let's do multiple of x. And let's include x up here. So that way we can get rid of this. And then multiple of x becomes a more multi-purpose function. So instead of multiple of 3, we'll do multiple of x. And in this case, we want x to be 3. We can change the rest of these as well. And we can see that the output is still the same. And yeah, that's kind of all I have, unless you guys have other questions.
Do you spend more time like debugging your work or like someone else's work, or do you spend more time like writing? hey, I'm like 15, like something happens, like, I'll just be like, oh no, like I have to go line by line and look at it.
Yeah, so debugging definitely is a big part of it, but I think the biggest usage of my time is actually planning all this stuff out. Like if you notice, most of this presentation was just breaking down the problem and like identifying the pieces of it. That's actually the most important part, because if you identify something wrong, then you'll write the wrong thing. And I think debugging, the amount of debugging you do will generally go down with just more experience you have. Like you're going to realize that, oh, I've seen this in my experience that this doesn't work, so I'm going to avoid that. I know that this works better. And you just become more familiar with the syntax. It's like learning like a second language. Like when you first start speaking a second language, you're going to mix some of the words up. But as you get more experience with it, you don't make as many mistakes. You guys did so much in 1 hour. You guys learned how to solve a impossible interview question.
Impossible.
Only 1 of 200 people answer it correctly.
Wait, hold on, Andy. This is the big question. Did you answer it?
What's up?
Did you answer it correctly in your interview?
I've never been asked this question because it's like too simple of a question. You really only ask it to weed out the people who say they know how to code but they don't.
Oh. So what's an example of a question to ask you?
I actually did not do very many complicated interview questions. So most of the places I interviewed at, they asked more practical questions. So like how to actually apply my knowledge to make stuff versus doing like arbitrary algorithm like questions that like are worthless basically.
So they ask you like a lot of system design questions?
Yeah, there's like system design, and they asked me about things like back-end paradigms.
Back game paradigm.
Back end.
Oh, back end.
Mhm.
I heard back game. Sounds good. I need to go back into the code.
All right, cool guys.